Welcome everybody. Can y'all hear me okay? Okay, sweet. So when I had hopped on Discord earlier, I thought that something was wrong because it was playing all these little sounds with everything. But I'm pretty sure that that's just their little Halloween package, which is kind of cool. But it seems like we have a good amount of people here already, so we should go ahead and get started. More people are going to gradually join us throughout the meeting. If when you join, if you don't mind muting your microphone, just to make sure that there's no feedback issues, and then if you want to speak, feel free to unmute and speak up. Just I want everybody muted just to generally keep things at peace while the presentation goes and happens. So today we are going to be talking about an introduction to web design and development. This is week 2 of Code Foundry. Now, if you are new to the bootcamp, which I think everybody here is came last meeting, but if you're new, what I do ask is that if you could please, you should have received an email which asks you to confirm your application and confirm your attendance. Please fill out that form. We'll talk about it more, and I believe in this meeting. But go ahead and fill out the application form, which there's a registration form. You don't have to fill that out if you're joining late. But we do ask is that you fill out the confirmation form, which basically will have you upload a bio and a picture that will allow us to just kind of identify you as part of the program. So please do that. Today we are talking about web design and development, which is exciting because we just got wrapped up in talking about branding and design fundamentals. Did anybody have any questions or thoughts about our last week, which was having to do with branding and design? It seems like no questions. If you do have a question, feel free to speak up and let me know. I'd be happy to answer anything that's on anybody's minds right now. So our goal for this program, for this meeting, is to talk about web design and development. So we're discussing tech industry development roles, intellectual property, which we have a special guest, our IP lawyer and consultant, Steve Swernovsky, I believe is how you say his last name. Steve. And Steve is our expert on IP for this meeting and our program. And he will be presenting on intellectual property for us, which is very important. And not just intellectual property, but also just kind of general startup law, which is very important, especially when you are a developer or engineer working on a product, as well as when you are creating your business and creating a product. So in addition to intellectual property, after we discuss that, we will be talking about the difference between websites, web apps, and API. What are they? How do they differ from each other? And how do they coincide? And then we will move on to discussing the 2 different kinds of web development approaches, programming languages and frameworks, and then we will be finishing out with wireframing and prototyping discussion. So this week's take-home videos, which weren't properly filled in this form here, will be about prototyping with Figma, and then the second take-home video will be about setting up your first website with Next.js, React, and JavaScript. So that is essentially what we will be working on. So we are going to move forward and talk about tech industry roles. So essentially there are a couple key roles in our tech industry that don't have to do with our executive members. Executive members meaning our CEO, our CTO, and our CFO, our executive people. And these roles include the software developers and engineers, our design team, our design staff, as well as systems engineers, QA engineers. And so we'll go ahead and dive into that. So here's a list of the roles that we're going to be going over. We're, again, not talking about business or executive staff, no HR, none of that. We're talking about our designers, which are our graphics, UI, UX, and product designers, software developers and engineers, our DevOps and cloud engineers, our systems engineers, our data scientists and our data engineers, and then our QA engineer roles. So the first design role, or the first role that we have here, are our designers. Here I've listed 3 types of designers, but design roles can be overlapping or expansive. Essentially, here we have graphics designers, which they typically put together marketing content, logos, pitch deck content. They'll design your presentations for your companies. In addition to that, they will design a lot of, put together your color, your branding package, right? Or they'll put together a package of icons that you can use with versatility within your business. And I like to say that designers aren't super necessary at the get-go, but it is helpful to hire a designer fractionally or on a contract basis to be able to design your logo or maybe your website. So that's more or less graphic designers. Then you have your UI, UX designers. They're the ones who design the prototypes for your websites and your products and your applications. And I find that UI, UX designers are crucial in development because designers will go ahead and create the prototypes for your websites and your applications, whether it's a mobile app or a web app or just a general website. And they do this using a process called wireframing, which we'll discuss today. And these prototypes, you can then hand off to development teams, and these development teams know exactly how the prototype is supposed to look, how it's supposed to work, the different buttons that you're supposed to press, the concepts behind the prototype. So UI, UX designers are crucial. I think that part of what makes it so crucial is that I see a lot of startups create products without designers. And what happens is they hand off their ideas to offshore development or even onshore development. And these development teams don't have anything to base their work off of. A lot of times developers don't have a lot of graphic savvy, so they don't know a lot about producing the right colors or producing the right imagery, and they just aren't able to realize the vision of the founder. So having a designer at the beginning and having them come up with the designs for the product and then handing it off to developers is very helpful. Another thing that is very helpful about having UI UX designers is that they can help create mobile and dynamic references for example, for your website. What happens when I change the page size, right? That window size. What if I decrease the window? How does that affect the website? And so what UI UX designers will develop is they will develop responsive designs, which will allow for the scaling of products. For example, your website on your telephone versus the website on the computer looks different. So that's what they do, and that's their role in the product development cycle. And then finally, you have product designers. Product designers are more for maybe you have a actual physical product with like embedded systems, robotics connected to it, or say you have there are lots of different roles for product designers. They look more at a top level view of the design. They also look at user experience, which is UX. UI stands for user interface, while UX stands for user experience. User experience has a lot to do with accessibility and how people are going to be using your product, in addition to expecting how they will also fail to use your product. So all 3 of these roles play a really key part in producing a beautiful product and a effective product, making sure that there is accessibility and accommodations applied to people who might, have a necessity for accommodations to how their website experience or their application experience interacts. in addition to advocating for your own design needs. So the next thing that I wanted to talk about is developers versus engineers. So the terms software developer and software engineer get tossed around a lot in development. And the reason being is that you have really both playing a role when you are building a product. But what people don't focus on is what the difference is until it comes to the hiring process. So the key difference between a developer and an engineer is that a developer is typically somebody who is knowledgeable about coding and has hands-on coding experience, but does not have a degree in coding or engineering. Versus an engineer has a degree in computer science, computer engineering, or some other engineering form. And what differentiates them is that when you are in school learning about engineering, you learn about software architecture, learn about engineering architecture, you learn how to look at a product from a very high level to a very low level viewpoint. For example, I went to school as a computer engineer and I graduated with my computer engineering degree. And in that process, I learned how to look at schematics all the ways down to the chips themselves in terms of hardware, and then how to actually put software onto that hardware, which was something that I consider invaluable because a lot of computer science programs only go over the software portion versus computer engineering gave me a broader aspect and a broader view there. But you can become an engineer even just being a computer science major. The real difference between developers and engineers is that engineers think in a more systems level view and approach versus developers think on how do I code this idea into being, which is more narrow but more coding centric. Engineers will typically start with coding problems as entry level and mid level, and then they will become broader and broader in their experience and their application of their engineering knowledge. Meanwhile, developers will typically stay as a code-centric, more low-level type of role until they graduate into becoming an engineer, which developers can become engineers after a large amount of engineering experience. So working on teams where they have to lead and actually come up with ideas and focus on the system level portions of these projects, that's when you start graduating into engineering roles and can start calling yourself an engineer. So in this cohort, we have a mix of people who have engineering and development backgrounds, which is really great because it really ties together people with different experiences who can contribute differently into different projects. So the next thing we're talking about is DevOps versus cloud engineering. These two are kind of interchangeably used roles because both have experience working with on-cloud technology. However, they can be broken down in bigger companies into smaller roles. So DevOps has to do with how your code is deployed and developed and operating. What DevOps engineers do is they create pipelines from your code base, which is where you store all of your written code, to production level deployments. So DevOps engineers focus on how does my code get from our code base with version control, which basically outlines how your code is deployed, whether this is an older version or a newer version, and they manage that, and then they manage the pipeline from the version control to the actual deployment structure, which is typically on the cloud. So that's why they mix with cloud engineers. However, cloud engineers differ in the fact that they work a lot with these cloud service providers like AWS, Azure, and Google Cloud. They work on taking the code that is supplied through the DevOps pipelines and spinning up the actual servers necessary to produce the final product. So they work more on production grade code. A lot of these DevOps or the cloud engineers and DevOps teams work together on telemetry and receiving feedback from the actual product and storing that feedback so that you can analyze for bugs, issues, as well as providing telemetry to other applications like dashboards. What telemetry means is it is real-time data that is coming from a product. So a lot of times telemetry will be coming from hardware and sent to the cloud. So you'll receive real data from the hardware that's on the ground, and then you'll be able to take that from the cloud and then display it on a dashboard using a interface created either with a web app or a on-system application. So that's the idea there. Cloud engineers work a lot with the actual production level code on the cloud, and DevOps works to create the pipeline between version control and the cloud. But both have to do with cloud software and deploying multiple versions of code. Then you have systems engineers. Systems engineers tend to have a broader level of focus when it comes to developing products. You have the system engineer as a whole, which typically looks at both mechanical hardware and electrical and also code. But then you also have what is called embedded systems engineers, which is what I am. Embedded systems engineers specialize in producing software that goes onto prototypes or onto firmware, or it works as firmware on top of robotics and mechanical components. So we work a lot with motors, we work a lot with developing these telemetry systems, which can then report from sensors and record data and then display onto online dashboards. That's how I got my start, was as an embedded systems engineer. Systems engineers look at a lot of different disciplines and combine them to be able to give a high level to low level view of how your system is architected. Then you have data scientists versus data engineers. The difference really is that data scientists deal with modeling and analyzing trends and being able to assess how those trends influence the product as a whole. A lot of times they work with AI and machine learning in order to be able to predict trends for your algorithms and your product. Meanwhile, data engineers work a lot with the databases and the actual hard infrastructure for storing your information. So in our case, we typically have data scientists extracting data, while data engineers will inject data. So those two roles are commonly confused, but they intermingle, and data scientists can also work with full service, full scale technology, as well as data engineers. And then in addition to that, we have quality assurance engineers. What QA engineers do is they test the product to find errors. QA engineers are very commonly used in web application aspects or also mobile application. They make sure that your application is responsive and works well with what the UX designers intend, so how your user experience functions. Quality assurance engineers work with a unique set of tools that will interact with the browser or the application, and they'll come up with the unit tests and kind of the tests that assure that the product is working effectively. And then finally, we have full stack engineers. So we've talked a lot about the difference between developers, engineers, designers, all of these different disciplines. But this term full stack engineer gets tossed around a lot. Now, full stack engineers used to just be somebody who specializes in both front end and back end deployment. Front end is typically what you see in an interface. So it's what we get at face value from a website or an application. However, back end engineering is conducting the actual development in order to create the systems that will produce the data shown on the front end. So back-end engineers deal with the orchestration of data and back-end cloud systems, etc. Back when cloud was not as big of a thing, this had to do with ingesting and returning data. However, now that cloud has become such a big role, a lot of full stack engineering requires cloud experience with either AWS, Azure, or Google Cloud. In addition to that, a full stack engineer is not only knowledgeable about cloud engineering, but is also knowledgeable about DevOps pipelines. So as a full stack engineer, you should of course be able to know how to publish code with Git and how to version control, but also know how to set up version control pipelines and DevOps pipelines with systems like Git's version control and Git's pipeline system, but also Jenkins and other DevOps pipeline systems there. So full stack engineers really dabble in everything. You should have a core in front end and back end, and really you can specialize. The goal is to specialize in either front end or back end. It makes you a better candidate for jobs when you're looking to actually apply yourself. However, full stack engineers should have knowledge of both, as well as cloud engineering and cloud orchestration. You should also, as a full stack engineer, know how to perform code reviews and how to provide code tests, similar to what QA engineers do as well. In addition, I feel like this is a great spot to mention what I call full stack design. Full stack design is not a term that's commonly used, but it's a term that I like to use when I advocate for myself as both a designer and an engineer. What I've defined full stack design as is it's being able to design a component with prototyping and graphics and content management, and then be able to take those designs and then full scale be able to provide a product from those designs. So taking the UI UX design, producing a website or a web application, and then not only being able to do that, but then being able to take that web application prototype or that web application that I coded and deploying it onto hardware. So full stack design, I feel like, is a very important skill because a lot of designers don't know how to code. They just know how to bring the concepts to reality. And so having a full stack design perspective is really valuable. So now I'm going to hand things over to Steve, our IP expert, who will discuss intellectual property and startup law. I'm not too sure if he has a presentation ready, or I think we had talked about that, but it's up to you. I'll give the mic and the presentation over to Steve. So Steve, if I can hear you, if you want to share your screen, go ahead. I'm going to stop sharing my screen here. Sounds great. Okay. Perfect. So that is kind of closing out our intellectual property and startup law portion. One thing that I wanted to mention was that I am going to be adding to our resources document the a sample contract for startups to when hiring developers, and that sample contract or agreement is going to be added to our resources file. This was written by a different legal group. This was written by Dean Elzab, I believe, of Elzab Law. And so he had provided this contract for us to use as a model of what a agreement looks like between a company and a developer or an engineer or some other agent. So you should see that tomorrow in the resources document. And for everybody who is new, our resources show up in the Bootcamp resources channel of our Discord. So go ahead and keep a lookout for that. So normally we would move on to a water break, but because we only have about 30 minutes left, we want to move on and discuss websites, web apps, and API. So the rest of this lecture is going to be about websites and developing websites. There are a couple different keywords, including websites, web apps, and API, that people typically toss around, but I wanted to clarify what these terms mean. So what is a website? A website is essentially a collection of pages that can be found on the internet. The internet is a network of servers and essentially cables and routers that will detect and find where to go pathwise to find code that's being held on a server. So a website is just a bunch of code that's held on a server in the form of web pages, and whether those are dynamic, static, we'll talk about in this presentation. So I actually just went through this with my students. I work as a high school teacher part-time, and today I decided to sit down with them and say, hey, do you know how the internet works? And of course they're all scratching their heads. So I like to ask this question a lot. Do you know how the internet works? Because the internet more or less controls a large portion of our lives. After this meeting, I am going to have some dinner, and then I'm going to watch some TV on Netflix. And that uses the internet. Tomorrow morning, I'm going to wake up and I'm going to get on my laptop and work, and that requires the internet. So the way that the internet works is it is a series of networks and routers that will essentially retrieve data from a host server. So when we go on the internet, we use a browser, which is on our computers. So the browser is essentially an application which allows us to ask and retrieve and display information that is on these host servers. And what our browser will do is it'll contact our internet service provider network through our internet router. So for example, we have our internet router with AT&T or Astound or Spectrum. And that router connects us to a network. And so we'll go ahead and contact our internet service provider network and through our router, and that router network will contact fiber optic networks both regionally and internationally. So back in the day, the internet was supported by a lot of satellites, but these days satellites aren't typically used. I just have a satellite there because it's easy to picture. Satellites would receive our signal and then direct our signal to where it is supposed to go. However, in modern day, our signal travels through fiber optic cables across the globe, really, through undersea networks, right? So we have all of these cables that are strung across the ocean in deep sea networks, and they carry data across the ocean and back and forth between continents. So typically what would happen is you make a query or a request from your computer, which will go to your router. The router will receive the signal from your computer or your device, and then send it through a series of cable networks within your city and within your region. And what that network will do is it will try to identify the domain name server. So the domain name server comes from your domain provider. So for example, a domain name is www.google.com or www.hispanichackers.org. These domain names hide the server IP address and server information behind a really easily recognizable name. And that domain name can be searchable, and the location of the actual code that is the server that's held on the host server can be found by referencing the domain name in the domain name server. So we essentially go and send our request, and it searches for our domain name server, which matches our domain name, such as hispanichackers.org, with the location of the host server. And so with that knowledge, the location of the host server, it'll then re-reference, go back through our optic network, and it will find the host server where the code is actually held. And this is a really rudimentary kind of high-level diagram here. But essentially, we will go through our fiber optic networks, and sometimes that has you going internationally. Most of the time, that requires you to only find your information regionally, because a lot of host servers send your code to different points over internationally so that it's easily reachable regionally, right? So your code might be hosted in both China and in the US. So instead of having to send your search request all the way to China, it only has to check the US. So our host server is where we keep our code. A lot of times there are several servers that host your code in different regions. And our domain name server is what hosts your domain name and can provide the location of your host server when you send your internet request. So that's essentially how the internet works. It's a series of cables, routers, which will route your request to where it needs to go, and servers, and then also your computer and edge devices. So there are two kinds of websites when you're actually searching the internet. There are static websites and dynamic websites. Static website examples are, for example, wikipedia.com, which doesn't take like live input in, but rather just shows input out. Even Wikipedia, however, allows you to submit forms and submit data to them. So even Wikipedia wouldn't be a good example. Maybe like, for example, if you go to like worldwildlifefund.org or some of these websites that just show data that is kind of fixed, right? The data doesn't change. It's showing you just normal data that somebody has written, like an encyclopedia, essentially. So the way that static websites work is that as programmers, we program the information in ourselves and then we deploy it, and it's always the same no matter where you're looking from it. However, dynamic websites, on the other hand, take in user data and they return data from the server. So a lot of times that's showing live data, that's showing updated data by other users, forum pages, dashboards, all of that are dynamic. And dynamic websites generate new pages dynamically based off of user input. So for example, on Facebook, when you, for example, create a new post, that might create a new page related to that post, and creating those pages create dynamically. So that's how dynamic websites work versus static websites. Another term used with websites are HTTP versus HTTPS. When I send links, I always make a express attempt to use the HTTPS format, because HTTPS specifies that the interactions and the requests made to that website will be made with the Secure Socket Layer, or SSL. What SSL does is it encrypts all of the requests going in and the responses coming back, so that you can be requesting information securely. The reason why that's important goes back to our diagram here, where we are making requests to our host to find our host server, and there are all these different points in our journey to find our host server where we can essentially, our data can be exploited. So say we're sending our username and password to uh, a server running our code, right? So we send our username and password. It's going through this whole entire network of endpoints. And if somebody taps into an endpoint, for example, a lot of times people will hack into the router's network at like a public location, at like Starbucks, for example. So say you're a hacker at Starbucks and you've somehow tapped into their router. Now you can see traffic going in through that router and to the host server. So in this case, it makes it and exposes malicious attacks. And that can be potentially dangerous if you are trying to submit high vulnerability information. So that's why we use SSL, or Secure Socket Layer, and that's why we want to access HTTPS sites. Now, when you're creating a website, you can specify that you want all traffic sent to HTTP to be transferred to an HTTPS site. So a lot of times you'll search an HTTP site and it will automatically redirect you to the HTTPS version of the site, which is important because you want all of your traffic going to the secure encrypted format so that you aren't blamed when they get hacked. So HTTP versus HTTPS is an important topic here. Application programming interface is another term that's very frequently used. So what APIs, or application programming interfaces, are is that they are a way to get information usually formatted in JSON format. So that is a very easily accessible data format for websites and web applications. And what this does is it is information that is hosted on a web page. But instead of showing you live dashboard or live information that's specially formatted, instead, when you access that web page, what it does is it just returns data, whether it is an integer, which is just a number, or whether it is a string, which is just a piece of text, or whether it is a rich data type like a object that has, and we'll go more into this later, but a object with data that has multiple facets. Maybe you have the status showing up as a status number, and you also have a indicator text that gives some sort of context for the number, and you can return that. And so what APIs do is they allow us to communicate with servers and return information in raw form. And what APIs are used for is they're typically used for connecting applications, both sending data to the application and returning data from the application, and in a way that only developers can implement this. So APIs use this form of requesting and returning data. Um, as a developer, we implement APIs into our application to be able to retrieve data from other applications and to submit data to other applications. APIs are also used to send data to our backend and retrieve data from our backend. And the backend provides all of the code logic. So that's why APIs are very important. And we'll have more hands-on examples of what APIs are and how to develop an API later on in the program. So a couple website components are the code base, which is our code written typically in HTML, CSS, and JavaScript, and kept in version-controlled repositories like GitHub or GitLab. Version control allows us to create new versions of our application and website. So being able to roll out new code on our application in a production level system where we hold back the buggy code and we're able to deploy the code that's most important to our application. So version control allows us to control what format of our application is being shown. And we hold our code in repositories, which is basically just a set of code files on applications or infrastructure like GitHub or GitLab. And we'll talk more about that later. Our code is typically structured as HTML, CSS, and JavaScript files. which is also part of this presentation, which we will be discussing. A hosting service hosts the most up-to-date version of the code. So unlike our version control repositories, which GitHub and GitLab are a part of, our ways of hosting those, our hosting service typically hosts our most up-to-date version of our code and returns it when it's requested. The domain registrar is basically a way to register the domain name, for example, hispanichackers.org or google.com. Our domain registrar is the access point that our code, that browsers search for when they're searching for making an internet request. So for example, if I'm searching for hispanichackers.com, it's going to go to the Hispanic Hackers domain registrar, which will provide all of the location information for the hosting service that keeps the website code for Hispanic Hackers website. And then it will go ahead and trigger a series of events, which will go ahead and find the code on the hosting service and then return it back to the user. There are also email service providers. Oftentimes, the email service provider is the same thing as the domain or hosting service providers. But what the email service provider does is it gives email features, such as being able to send and receive emails to our domain and hosting services. And then you have the SSL certificate or secure socket layer certificate. The secure socket layer certificate stores encryption details for safe internet data transfers over your website. So there are a couple different web development approaches, which I will be showing now via my, I have a website that essentially gives some advice to startup owners and new developers on how to create their first products. So there are two types of websites. There are programmed websites and content management system websites. Programmed websites are your bread and butter, right? Your JavaScript, HTML, CSS, the websites that you are coding yourself with programming languages. These require hands-on development, while CMS sites like Wix, WordPress, Squarespace, these providers provide tools where you can just drag and drop components. Another benefit to CMS providers is being able to produce content such as blog posts or media posts. So CMS providers streamline the production of websites. So I'm going to go ahead and share with y'all my website here. My website is drebarrera.com. This is a personal website, and I've created the Startups Center to essentially help people with new startups. It's a work in progress. I actually created this several months ago when I was in Asia traveling and had some time to kind of sit down and work on it. And essentially, I just wanted to give a ton of information on how to start your startup. So this goes into where you are in your startup journey, but what we are focused on is building a website. And here we have an example of our CMS, our content management systems versus our modern web applications, which modern web applications are typically built with programming languages and frameworks. So we'll talk about programming languages and frameworks in a second, but first I wanted to compare building a website with code versus our content management system. So the benefits of using a content management system like WordPress or Wix or Squarespace is the ease of use, the low-code content creation abilities, the quick deployment. They typically have a lot lower development cost if you're having a developer build them, and they're so easy to use that you yourself could build it or a designer could build it. In addition to that, they provide customizable templates, third-party plugins and tools, built-in SEO and analytics, and we'll go more into SEO at a later date. Non-technical design features, they're more easily scalable, and they typically have built-in admin dashboards and technical support. On the modern web application side, these applications are highly customizable. They're granularly managed because programmers develop them from scratch. You have a lot of control over backend logic, optimization opportunities, scalable architecture options. There is configurable infrastructure, data-oriented telemetry options, enhanceable security features, full product visibility, third-party integration options, and low cost and open source. Because programming languages and frameworks are typically open sourced and are free to use. However, developing with them cost more. So in terms of cons, CMS sites give limited customization options, which is frequently an issue when you're trying to build a dynamic website. So I would say CMS websites are a lot better for static websites or websites that require a blog or some sort of media platform. In addition to that, CMS sites are dependent on platform updates. They have limited management features. They can be inefficient when scaling. There's a limited control over the back end. There can be third-party vulnerabilities, data security dependencies. They also require low project complexity, meaning that there's just there's limited flexibility. There's a focus on content over data, and there can be expensive subscription fees, which is typically the con for me. On the other hand, creating a website from scratch requires a high degree of coding, higher development costs, steeper developer learning curve, especially depending on the framework or languages used. It requires specialized talent, a higher project complexity is related to it. It is reliant on having a developer. So, and not just reliant on having a developer, but the security and the efficiency involved revolves around the developer's knowledge of implementing security protocols and efficiency protocols. It also requires SEO and analytics efforts, more documentation, and preparation for scaling. So those are some drawbacks to both of these and pros and cons of both of these systems. I highly recommend that y'all check this webpage out if you're looking to get a startup. But this is my own personal portfolio, so if you're interested to know more about me as a developer, you can also reference this website by clicking on this header button or checking out one of these links. In addition, I have information comparing the different content management systems. When it comes to using a CMS system, this is the popularity that Google Trends provides for all of these different CMS providers. So WordPress ranks number 1, with Shopify coming in as a second, Wix being a third, Squarespace being a fourth, and Drupal being a fifth. And then down here, I give the pros and cons of each of the CMS providers. WordPress tends to be the most popularly used, and it gives it the option of programming using PHP, HTML, JavaScript, and CSS, and also giving you a drag and drop interface. So it's very highly customizable. The free plan is using code strategies yourself, versus the paid plans typically provide drag and drop options. Meanwhile, there are other popular frameworks like Shopify, Wix, and Squarespace. Shopify can be programmed using HTML, JavaScript, and Liquid, which is their own programming language. Meanwhile, Wix and Squarespace are no code. Drupal is another option which can be programmed using PHP, JavaScript, and MySQL. But the benefit of using these CMS frameworks is that they can opt for no code or low code solutions. Low code meaning very little code. These are a couple other honorable mentions in terms of CMS providers. Meanwhile, when we're talking about modern web applications, we are looking at Next.js, React.js, Vue.js, AngularJS, and Express.js, ranked in that order. This shows the trends of each of these frameworks in popularity, and these frameworks provide a structure and set of code for your project. So we'll talk more about what a framework is in a second, but choosing the right framework is very important. So I'm going to switch back over to our presentation. We've gone over what a content management system is. They basically offer the ability to create blog posts and other kinds of content, along with providing drag and drop options or low code or no code options for producing your website. And this is our comparison. So let's talk about programming languages. There's a lot of different programming languages, and they're very broad. They go from very high level, which is very very easy to write, very less specific when it comes to editing the hardware on your computer or working with the hardware on your computer, to low level programming languages which operate very close to the hardware on the machine. When we're talking about web programming languages, we're looking at CSS, JavaScript, and HTML. HTML, or hypertext markup language, essentially looks like this. We use a set of tags. For example, each one of these pieces of text within the greater than and less than signs is a tag. So the top tag is our doc type tag. Next is our HTML tag, then our body tag, and then inside of our body tags, we have our header tags, which is H1, our paragraph tags, which is P, and our divider tags, which are div. So the way that tags work is that they structure our website. The HTML tags provide the overall container for our website, and inside of our HTML tags, we can put a header, set of head tags, and a set of body tags. In this site, we're not showing our head tags, mostly because head tags are used to provide data that Google and search engines use to display the website, versus our body tags provide the actual content of our website. Our body tags provide content like our headings, our paragraphs, and our images. So here we have a heading, a paragraph, and then a div, which is a square that's being produced on the website. And we are giving it style information, such as coloring our text red with the color, what's it called? Component. It's not a component. There is a term. Damn, I completely blanked. But the more on this will be described, and not element, property. That's what it is. So we have different sets of properties which can be used to style. But thank you for that. To style our web page components. And so here, for example, we have a height property, and we're giving it 50 pixels for height, 50 pixels for width. Here we also have IDs and classes. These properties essentially give the ability of giving it identifiers. So when we're talking about our CSS, which is our style sheets, we can reference these different elements using their identifiers and their classes. So CSS allows us to specify our properties in a separate sheet. So instead of having to specify our properties and our data properties in our actual components, for example, in our paragraph here, which makes it very verbose, we can instead say, for all headings, let's color them blue. Or for all elements with the identifier or ID square, this hashtag or # basically means that we are referencing the ID of square. We are making the squares all have a background color of yellow. The dot refers to classes, and we basically say with all components with the class name note, we are giving it a font family of Helvetica. So CSS allows us to apply our styles very broadly, and it also allows us to apply specifically styles to elements with specific element IDs or classes in terms of separating our styles from our components to another sheet. JavaScript is a scripting language that allows us to manipulate our website and interact with it. So this is our third programming language that typically websites are programmed in. JavaScript is used, for example, here, where we are saying, let's create a variable called square and store the document's square element, which is the first element that it finds with the ID hashtag square or pound square. And it's storing that in our variable square. Now we're creating a new header element with this create element, and then we are going to data scrape our URL here by making a API request, and with our response that we receive, with the data that we receive, we are putting that data in our header element, and that is what is going on here. So what JavaScript does is it allows us to interact in real time with our application. While static applications use HTML most frequently and very little JavaScript, dynamic web pages will use JavaScript to allow users to input data and receive live data or new data accordingly. And so JavaScript allows us to have a level of dynamicism with our data and interact with it and create some really cool interactive ideas, like, for example, video games use a lot of JavaScript to allow interactivity. We can animate things with JavaScript. We can change the properties based off of user input with JavaScript. We can do a lot with JavaScript. And more will be given on our take-home videos and the content of our future lectures. So finally, frameworks allow us to create products with already pre-written code. There's a lot of different frameworks out there, and I think I'm going to hold off on going over our frameworks until next meeting. But what you need to know about frameworks is essentially frameworks abstract our code and our programming languages by giving us already pre-written code to pull from. And it also provides structural components to how we set up our websites. There are frameworks for both websites and normal applications. And frameworks basically give us a stronger level of efficiency as programmers. Back when I started programming, the only framework that was really popular and out there was jQuery, which was a library that you can import and allows you to do some really cool animations and edits to your properties on your web page without having to program all of the nitty-gritty data level program content, right? But now we have Angular, Vue, and Next.js, or React.js, which are very important and very popular because they make it way more efficient to write code. Finally, the last thing I wanted to cover, which we'll cover in the last couple minutes, is wireframe prototyping. Wireframe prototyping is creating diagrams that will exist as your prototype without any code using applications like Figma. And as an example, this presentation has been created in Figma. So as you can see here, these are my wireframes for my Figma prototype. And you can zoom in, and I have a set of slides, and each slide has different components and different items. Our first take-home video is going to be about creating component prototypes and components with Figma. So Figma is a really important industry standard, and it gives us a lot of options for prototyping, whether it's creating an application prototype or something like this, which is a presentation. So I wanted to give a project update. Essentially, we have not been able to find a second project, but if anybody is interested in bringing a project to the table for our boot camp, please let me know. But we do have Ion as a project, and we are also offering the ability for y'all as boot campers to practice your skills using your own projects that you can specify and decide what that is. So what I'm going to ask everybody to do is please scan this QR code, which will take you to an attendance webpage. What that webpage will do is it will have you input your name, your email, and ask you some questions about today's lecture, what you found most helpful, and what you're thinking about doing in terms of project. Whether you want to jump on our group project, which is Ion, led by our great I believe his name is Josh. I'm so sorry if I got that wrong. It's Josh Flesher. Yes, Josh. Um, and then and then he will be leading the group project with his application Ion. And then if you want to work solo and do your own project, you can also specify that in the form. So please scan this QR code, fill out your form to mark your attendance. This helps us understand who is coming to our program and who is using our resources, and also whether or not to expect you at our next meeting. Now, another thing that I'd like to mention is that if you are going to be attending our next meeting, please go ahead and go to our meetup page, which is where you found our Discord link. Go to our meetup page and subscribe to our next event, which will be next Monday. We meet every Monday from 7 p.m. to 9 p.m. as a hybrid boot camp. Next meetings event will be online on Discord like this. So I'm going to put this attendance link in the chat after this meeting. Please go ahead and fill out your attendance. Yes. Great question. So Josh and I have to talk about what limit he wants in the number of developers on his project. But what we'll do in the meantime is please fill out your interest in this form. I can actually show you what the form's going to look like. The form is going to look like this. So it'll have you put in your name, your email, what part of today's meeting was most helpful, and then down here it describes our two project options. You can go ahead and select your interest for Ion. It asks us how you're feeling about the project so far. This is mainly to gauge in the future how you're feeling about the project and your interaction with it and your contribution. And then giving feedback about how your project is progressing so far, asking any questions that you'd like to be addressed. Now, what we're going to do is from this meeting on, if you have expressed interest in a project, we will reach out to you and either ask you what your project is, which choosing your own project requires that you send the name and description of your project to hispanichackersboard@gmail.com. Or if you choose Ion, we will be reaching out to you about whether or not you've made it onto the Ion project this upcoming week. So I know things are off to a kind of latent start, but our goal is to get everybody on board. This is the first time that we've offered this boot camp, so please bear with us as it takes us a minute to get geared up. Does that make sense? Of course. Does anybody have any questions? Any other questions about anything in the lecture? Sweet. Okay, cool. So this has been week 2. Your take-home things to do is this is actually a QR code for our Discord. You're already on our Discord, evidently, so no need to jump on there. If you are interested in our in joining us weekly, please let me know and fill out the appropriate forms. There is a welcome form, which I don't know if some of the people who came from Meetup might not have filled out, but please go through the form that's on the meetup page if you haven't already and fill out your application for registering for weekly classes. In addition to that, we are providing 2 take-home videos today this week on Discord. The first one will be released on Tuesday and will be about wireframe prototyping with Figma. The second one will be starting your first Next.js website project using Next.js and React.js, which is what we will be using for building our websites and web apps in this class. In terms of projects, we will be assigning projects this week. The first thing that I want y'all to do is discuss and share your brand, logo, slogan, mission, and values. Come up with a set of brand standards for your brand content, and then start wireframe prototyping your project's website using Figma. There will be more information on this on the resources page. And I believe that that is all for today. Thank you all for joining us. If you have any questions, please direct them to me either on Discord or at my email, hispanichackersboard@gmail.com. Thank you all, and if you have any questions, feel free to stay on and ask me.